everyone. We're going to get started mostly close to on time. Woo, go us. For those of you who are new here, this is the Middlebury Science Café. We meet every second Thursday right here in the community room of the Isley Public Library. We do a whole host of topics, so just like the weather, if this isn't your jam and it changes next month, you can follow us on Instagram, and we also post on Front Porch Forum, and you can see stuff in the library newsletter. Now, I know you all didn't come here to hear me talk, so I'm going to go ahead and turn the events over to Patrick, who is going to be talking about severe weather right here in Vermont.
Thanks, Catherine. My name is Patrick Wikstrom. So good to see all of you here. I work up at Middlebury College as the Climate Action Coordinator, part of the Climate Action Capacity Project with Minna Brown, who's right there in the purple. And we help students find various forms of climate action and kind of mentor them, and also host a variety of climate events on Middlebury's campus and with the community as well. I have a background in meteorology and climate change science. I forecasted for VTrans, doing winter weather forecasting for them, the winters of 2020 and 2021. I've done research with climate modeling as part of the EPSCoR project of Vermont, which is a huge climate research project that the state has commissioned to understand climate change impacts in the state of Vermont. And then I've also done research with Northview Weather, which is now Disaster Tech, on verifying their modeling for solar energy in the state of Vermont, using a solar energy model that they created for the state utilities to use, specifically looking at green mountain power to better forecast using the weather, and what people do daily to better forecast electricity, to basically make the electrical grid more reliable for customers. So today I'll be talking about severe weather safety in the state of Vermont, the risks that we have here in the state, how to deal with those risks, especially in an ever-changing climate that we live in, and then also kind of going over a little bit more of the climate change risks as well, and how severe weather is changing because of climate change, and kind of honing in on the state of Vermont and kind of what we're going to be seeing for the state. So I'll kind of start by, a lot of these pictures that I have are pictures that were either taken by me, my friends, or my family. This is a lovely photo from the Lindenville campus of Northern Vermont University overlooking Burke Mountain, and there was a severe thunderstorm in the spring of 2019, and one of my classmates, Brendan Ruff, took a video, and it was the right place at the right time. We had a rainbow, a thunderstorm, and a lightning strike all over Burke Mountain at the same time. It was in the evening, so I thought it was just as fitting to throw that in there and credit my friend Brendan for taking this photo. And so yeah, so just to get started, I kind of wanted to open it up to you guys to understand what you would perceive as severe weather, and to kind of like understand or like what your risk tolerances are by, you know, kind of hearing what you would consider severe weather, whether it's hail or lightning or tornadoes, so on and so forth. So I'll kind of open it up to you guys to hear a little bit from you guys of what you would consider severe weather.
The fact that we had a tornado on Painter Road a couple of years ago.
Yeah. Great example. Anybody else?
Well, I would think anything that's out of what we expect.
Anything out of, that's a good one as well.
Anything that's like, I mean, I suppose anything over a certain amount of like duration could be really harmful, or anything that's like a great drop of something.
Yeah.
Or a severe plunge in temperature, like something really severe that's actually very harmful.
Yeah, something really drastic happening all at once with little preparation time.
Yeah.
Yeah.
Oh, that windstorm that we got?
Yeah.
Yeah.
That one, we actually got FEMA declared money from that. The state just got access to that for FEMA damages to the grid. So that's a really good example of severe weather. So kind of jumping in, severe weather is any of this, or the results of it. So most of these pictures are in Vermont. There's a couple that are outstanding. So this one is a tornado that my cousins actually took a picture of in Shreveport, Louisiana a few weeks ago. That is a picture of the Doppler radar in Lake Charles, Louisiana, as the aftermath of Hurricane Laura. Radars withstand I think it's upwards of 210 mile per hour winds. But if it's completely being pummeled by a Category 5 hurricane for a while, it's going to break down. We have my favorite over there. That's we had a significant freezing rain event in the Northeast Kingdom. I'm not sure how much it affected the rest of Vermont. In spring of 2019, I had to walk to calculus class over that because my professor was already on campus by the time it started. And we all were like sliding into class, and Doc was like, wait, why didn't you tell me that it was freezing rain? And we're like, well, we can't help that you get to campus at 3 a.m. to go and work out and play basketball and stuff before our 8:30 class. It's like, I would have canceled it. And then we proceeded to learn calculus 2. And we had to kind of shuffle back in that fashion as well, because he was also old-fashioned and refused to use email, even though classes were delayed. Those are all really good examples of severe weather, whether it's far, seeing anvil clouds here. This is also in Vermont. This was in August of last year. Whether it's in the distance of severe weather, or it's up close as winter weather. Winter weather can also be considered severe. That was after a snowstorm in 2020, right before the pandemic. We got, I think, 18 inches of rain, or 18 inches of snow, and then the blowing snow, we were about 24 inches of like blowing snow that we're burying our cars in, which was thrilling to dig out afterwards. But all of these can be considered severe weather. So kind of going into, what severe weather impacts us the most. Unknown to a lot of people, heat is actually the biggest killer when it comes to severe weather. And in a warming climate where we're seeing more heat waves and heat waves lasting longer, this is an extremely important thing to know that is a hazard. You can look at the Pacific Northwest a couple of years ago, whenever they had a heat dome basically park over the region, and especially in a region with very little central air, and even people who own window units, it can become deadly really fast. It is also really important to note that these numbers are from 2021 and are severely underreported, because in the case of heat, you might have somebody go to the hospital for a heat-related illness for the day that they might, during a heat wave, but they may pass away from other complications a few days later. Or same thing with hurricanes, especially. You might have storm surge. You don't necessarily know that the storm surge was the cause of death for study, but can lead to factors that ultimately led to their cause of death, whether it was a failing power grid, being trapped, and such forth, not necessarily drowning. But it is important to note that heat, flooding, rip currents, that's another one, although we don't really experience it in this lovely landlocked state. And cold and tornadoes are the biggest killers when it comes to severe weather. The ones that we'll be kind of focusing on here in Vermont that are more the hazards we want to pay attention to are heat, especially flooding, winter and cold weather, as well as lightning. Just because here in Vermont, those are the ones that we're probably going to see the most of. We're likely not going to see very many hurricanes, although we had Tropical Storm Irene a few years back. That is really not a consideration whenever we think about the day-to-day or more frequent severe weather events we might occur. Yes?
What does winter, since it doesn't include cold,
Yes.
does it include falling on the ice, car accidents, that kind of thing?
So winter weather would be that. So if you get stuck out in a blizzard extreme snow, you might get in a car accident due to unplowed roads, stuff like that would be considered more winter weather related events. Wind, that one also a little bit weird one to explain, but it's like getting hit by a flying projectile in a windstorm or a hurricane, for example, or a tornado. Tornadoes are notorious for fleeing debris to the point where we can see it on a radar. And so if you get hit by debris, that would be considered more of a wind-related death. And this also does not account for injuries. As we know, tons of people get injured by these events more frequently than not as well. Now, kind of going into everything that you are going to interact with on a day-to-day basis. So these are the national, so we're going to go into like the National Weather Service products. This is the #1 confusing piece for the general public to know, conceptualize. You get the alerts on your phone, whether it's a severe thunderstorm watch, warning, a blizzard warning, whatever it may be. You get those and you're like, okay, cool, there's a blizzard coming. What does that mean for me? And it is confusing. There's 43 active advisory, watch, and warning products for the National Weather Service. All of these you might not experience in your region, such as the ones that may be more for marine weather, we might not see as much here in Vermont, as well as the ones that are more tropical related. We're not going to be seeing those popping up nearly as much here in the state, such as hurricane watch or hurricane warning. Also, to note, watches and warnings, that's an important distinction that, that not a lot of people understand as well. So typically when it comes to thunderstorms and tornadoes, basically a watch, essentially the best analogy is the taco analogy. Your ingredients to make a taco are sitting in front of you. A warning is saying the taco is here, it is imminent, it is put together, it is assembled. Like in the sense of a tornado watch, all the ingredients are there. You're going to have a lot of instability in the atmosphere and amongst a bunch of other variables. And then the taco warning would be a tornado warning issued by the National Weather Service saying there is a confirmed tornado either by a spotter, radar indicated, or we physically see it on a webcam somewhere, and that you need to take cover and shelter immediately. There's also, National Weather Service is also always undertaking reviews of these products, and it takes years for them to develop these. So they're always looking on how to improve them because the lifeblood of a meteorologist is to protect people and property foremost as your job. And so they want to know how to better communicate these products to people and make them easy to understand, while also making them adaptable to our changing climate. So one of the things that they're working on right now is emergencies. So tornado emergencies, for example, have been issued a lot this year, and that's for tornadoes that are staying on the ground for like dozens of miles and tracking a really long ways, and that are also really powerful, like the ones we've seen in Mississippi and Indiana this year. So those are also important to note. We will likely not see a tornado emergency because of Vermont's terrain and the other factors. So the tornado emergency would likely not be used for Vermont because that's only in the most severe cases. We would probably only see a tornado warning, for example. Also important to note, you will either see a watch warning or something pop up within hours of an arrival of something, or you might have only minutes warning, such as in the tornado warning. You have on the average, the National Weather Service has, I think, about a 10-minute lead time on tornado warnings specifically, and that's just because you can't forecast exactly where a tornado is going to be at any point in time until all the ingredients start pulling them together, and then they can start issuing watches for specific geographical areas, and then once it's detected, then they can issue a warning. But yeah, and also another thing as National Weather Service offices, depending on where they are geographically, they do have different standards for the way they issue things, such as freeze watches and warnings. A freeze warning here would be a lot colder of a threshold than a freeze warning in Texas, for example. And that they would issue a freeze warning probably when it gets deadly cold here. In Texas, it damages any infrastructure that is not insulated to the cold. They'll likely issue a freeze warning. Now, understanding these National Weather Service products, you all have access to them, which is an amazing thing. So on Monday, when we had the red flag warning issued by the National Weather Service in Burlington, that was indicating that, and I think we might have one today too, or it might just be a fire watch, but it was indicating that the conditions are there and available for rapidly spreading fires. If there was a fire to occur, it would rapidly spread because of it was windy, dry vegetation this time of year. So you have access to it. So this is a screenshot from my phone of Monday in your average weather app that you might use on a daily basis. And you see that you have the red flag warning issued. Well, when you actually click on these warnings and watches and statements, you can click on them and it gives you a whole slew of information. And this is actually going to be more useful than the information that you're going to see popping up where it's like your hourly forecast. That's all computer generated without a meteorologist input. So there's no human input behind that on a phone. Now, the National Weather Service, when they issue these watches and warnings, they give you a bunch of details, and these are written by people. So in the National Weather Service office in Burlington, at the Burlington Airport, they break it down for you, and they give you, for example, in this one, they tell you where the threat is geographically. So they have New York, Champlain Valley of New York, in Vermont, Champlain Valley, etc. The timing of the event, the wind speeds, the relative humidity, so the ingredients that are going to be the most contributing and the biggest hazards to this, playing into it, as well as temperatures, and how it's going to impact you directly. So any impacts you might see, it'll go into a little bit more detail in there as well. Also, sometimes they'll give you a little bit more additional information, such as there was a burn ban in effect for all of New York through May 14th. So they'll throw that information in there as well for you to have. So this is usually going to give you a lot better of an indication on how to act whenever severe weather might be a threat for the day, such as this, or it could be imminent in that moment, such as a tornado warning. So this is all really good information to have. Also important to note, the National Weather Service, on their website, they post a forecast discussion every day, and sometimes multiple times a day, where they talk about what the conditions are in our region. Each National Weather Service office services a different region in the United States. They make that forecast very specific to that region, and the impacts you're seeing, why it's happening, and when it's going to be happening. Even though they do use technical language, all of the technical language is highlighted in blue for you to click on and have nice definitions for the public to easily digest as well. And that's just not only service the general public, but also anybody in aviation, transportation, any public officials as well to understand.
Are these warnings written for Vermont as a whole, or is like, I mean, are they written, broken down into smaller locations?
Yeah, that's a really good question. So in terms of the example of using the red flag warning, they will use basically what we call a polygon system, and where they'll basically just box out sections of the geographical area that that office covers, and that's where this would apply to. So whenever they talk about the affected area, it's only impacting this affected area here, where they're talking about. So the lower Connecticut Valley, northern Taconics, etc. So like they're going to be a little bit more specific in these. I probably said that really wrong. This I'm so sorry.
But something like a tornado would be...
It would be very pinpoint in that for tornado warnings, because it's much smaller scale, and having lived through a ton of tornado warnings, they will list the individual towns that are affected too. So like at home, where I'm from in North Texas, they list there's a tornado warning, and it's issued over Burleson, Mansfield, Grand Prairie, Cedar Hill. And they'll list all the cities in order from start to finish of where it would impact, and they'll put timing associated with them. So they try to be as detailed as possible without trying to be like as confusing as possible, and they'll try to minimize the language as well. So the important piece is we know climate change is happening, severe weather is going to be occurring more frequently. So what can we do about it? We reduce our emissions, that's all great and dandy, but severe weather is still going to be severe weather, and it's going to be happening. So it's important to stay severe weather ready. So some important things that I kind of put together on here for people to know is knowing your safe space. So the National Weather Service has a campaign every year. Each office has a different time. The National Weather Service office in Burlington, they'll probably have it next week, I think is the 23rd is when Severe Weather Week happens. But they'll have a campaign at that time where you take a picture in your safe space locations in your home. Basically, it would be the most interior, lower portion of your house with the most walls separating you from the outside as possible, away from windows. In the case of severe weather, a tornado, for example. You don't want to be near a window, looking out your window at a tornado that's barreling at you, because even if the tornado doesn't directly hit you, it's flinging debris everywhere at the same time. And so it can pose a risk and a hazard there. So knowing your safe space at home, but also at work, is another really important place to be, because that's where you spend a lot of time as well. So you want to know where your safe space would be at work. And so, the building that you may work in, if you work in a Weir college like I do, then you would probably know that you would want to go to the lowest portion of Hillcrest. And it would, I believe, be our kitchen in there, or the bathroom right there as well. Also important to have when you go to your safe space, something that was always rolled into my head at home is grab a pair of tennis shoes. It's weird, I know, but grab a pair of tennis shoes when you go to your safe space, because if you get hit by any severe weather that might pose any structural damage to your property that you're in, you don't know what you're going to be stepping on or stepping into when you come out of your safe space. And having tennis shoes and closed-toed shoes is going to prevent you from stepping on a rusty nail and getting tetanus, for example. And it's going to help reduce that mitigation as well of any hazards that you might have in the aftermath. Also, if you have a chance, get a pillow, get a helmet, something to put as a barrier in between you and anything that might be a flying projectile. In school, we used to put textbooks over our heads whenever we'd have tornado warnings issued while we were at school. And that's because it's a hard object put over your head to protect from any blunt force objects that may be flying at you. So having your safe space known, and then making sure the tools that you know to have are there with you. Your Go kit is also important. So this is just basically any standard emergency kit that you would have in your car, for example. Vermonters are well prepared for winter weather in their cars, so I don't have to really go too much into detail of that. If you want to have a blanket, probably jumper cables. That way, if you get stuck on the side of the road, stranded, you're not going to be cold. You might have a snack or two as well in your glove compartment just to keep you warm until help arrives at that scene, because you also don't know when emergency services will be able to get to your location as well. In terms of emergency kit for more severe weather like tornadoes where it might cause absolute destruction, you're probably going to want things like water. A gallon per person per day is usually the standard, but luckily we have relatively close options in terms of, even though we're very rural, we're pretty close to emergency services, and it's pretty well connected. So you're probably not going to be stranded for days without water, but you want to be prepared for if you're going to be stranded for 2 or 3 days without any emergency services or anything that can help you as well. Cell phone charger, anything like that that's going to sustain you. Knowing where your medications are is also a really important thing, especially if you take a daily medication for things that sustain your life. You want to be sure that that's also at your handiness as well. Also, I put a couple extra things on here for you guys. So also don't just try to outsmart Mother Nature. Mother Nature will always outsmart you. Don't think you're going to outsmart her. It's better to be safe than sorry in these situations. But also, the National Weather Service, if you go to weather.gov/safety, it has even more detailed information about this, and it breaks it down by severe weather type about the hazards and things to do to mitigate those hazards based off the type of severe weather you might encounter. Also a fun one for Vermonters is plowtrucks.vtrans.vermont.gov, which is kind of a mouthful. You can track every plow in the state, when it plowed, where it is. It shows their plow name and everything. So in the winter time, as somebody who used to forecast for VTrans, I would use that as part of my forecast, but also whenever there's a winter storm, I hate driving in the snow, but if I have to drive, I'll go check that first, see if there's a plow that is either near me about to plow my road, or that just recently plowed and salted. That's a really good resource that a lot of people might not know about, and it's only for VTrans plows for this one, so if you have a town plow, it's not going to be on the tracker likely.
Is that like a GPS-based thing, or do they have to report in?
So it's GPS-based, so you can live, if you zoom in far enough, you can watch the little orange truck move across the state, which is kind of fun. And then you can also overlay the radar on top of that map, so you can see the radar along with where the plows are plowing, which is a pretty neat tool to have. And then 2 good sayings is turn around, don't drown, and when thunder roars, go indoors. So I know a couple of you guys are taking pictures, so I'll wait a second before changing the slides for y'all. Yeah, so I know that you brought up the Middlebury tornado earlier, so I kind of wanted to go into this as to show how quickly severe weather can happen. So this is directly from the National Weather Service Burlington. They do a multi-scale analysis after these storms. So basically, they go out, they not only have to survey the damage and determine what strength storm it was, but also they do research into it after the fact, whenever they have downtime, whenever there's high pressure systems parked over the state and they're really not doing too much in terms of forecasting, they're doing research. So they plotted out the track of the tornado, and they determined it was on the ground for 5 minutes. The estimated maximum speeds were 110 miles an hour. There were 2 injuries, full collapse of a garage and other roof damage, which is this house right here. And then a bunch of softwood trees had snapped, fallen over, such as this one, and there was a car flipped as well. So in just 5 minutes, all of this can happen. And so that's why it's important to know where your safe space is in your own home, and also to be aware of the weather whenever it hits. Some extra stuff to stay up to date, if you guys want to take a picture of this slide, it's also really good, is how to stay up to date with severe weather watches and warnings. I put a list of everything that I can think of off the top of my head of news stations, the National Weather Service, the emergency management officials, and the Vermont Health Cooling Centers is also a really good one, especially now that it's hot out. Those are all really good resources to stay up to date. Also, the tried and true method that usually never fails is a weather radio. So that's what the little red thing is there. And the National Weather Service, through radio waves, they send out emergency alerts through there. And if you don't have tornado sirens outside, or you're asleep and your phone is on Do Not Disturb and silent, that will be a surefire way of waking you up in a severe weather situation, and that it will be blaring noises at you. And it's a really good tool to stay up to date as well. Also, in your phones, if you have an iPhone, making sure you have your government alerts on in the notifications section. You just scroll all the way down. Here at the bottom, you have government alerts. So right below Amber Alerts, having emergency alerts on and public safety alerts are really good ways that you can stay up to date. So the National Weather Service, just like VSP would, send out Amber Alerts, the National Weather Service can send out tornado warnings, severe thunderstorm warnings in your area based off of the geographical area that you're in. So you can get those on your phone as well, which is really, really good information to stay up to date with. So enough with boring you. Or not yet. I almost enough boring you. We're going to start getting into like climate stuff now. But about risk perception with severe weather. So this is actually taken from a slide that I made in undergrad where we went over risk perceptions of severe weather and understanding how severe weather impacts people's perceptions on staying severe weather ready, but also like, making sure that you're understanding, where your safe space is and such. And basically what this shows is it was a study in Oklahoma City done by OU looking at risk perceptions of tornadoes and where they happen and what people actually think about tornadoes. And so in Oklahoma, you would think everybody must be like really like aware of like the risk of tornadoes, but actually it depends on the strength, when the last time it happened, and how close it was to you of the tornadoes. So weaker recent tornadoes actually had a negative effect on people's risk perceptions, and the same thing can happen with other forms of severe weather. So which is very noticeable in this part of Oklahoma City, so the northeast or the northwest side versus the southeast side. There was weaker tornadoes that happened in this area, and there's a lower risk perception with tornadoes. So people are willing to take more risks when it comes to tornadoes, and not necessarily take tornado watches as seriously or tornado warnings as seriously in their area. Versus on the southeast side of Oklahoma City, there's been stronger tornadoes, and that section tends to have a higher risk factor whenever taking into account tornadoes in the area, which is just like really important to know. Yeah.
And that just makes me think, like, here in Vermont, what weather are we not taking seriously?
I can tell you exactly what weather is, and it's winter weather. Because Vermonters, I have a friend, Michael, who lives in Bangor, Maine. He's a meteorologist there, and he notoriously gets messages from people being like, "Oh, it wasn't that bad," and he's like, "No, my forecast was right, but just like you specifically may have had all the right tools to deal with that severe weather, but the risks that are communicated are for those that, for the whole general population, assuming that you might not have those tools to be severe weather ready." And so Vermonters and people in the Northeast take winter weather less seriously than say in the South, where in the South you have a minuscule thin layer of ice come over the ground and everybody freaks out, bread and milk off the shelves, done for. Versus up here, you might have a blizzard and people are like, I got snow tires, it's fine. But when it comes to more severe weather up here, like if there was a tornado watch issued in Burlington, I guarantee you people will probably be very on their toes of like, why is there a tornado watch happening in Burlington right now? Versus at home in the South, everybody's like, oh, a tornado watch? Like, I can handle that perfectly fine. So different areas have different risk tolerances for the types of severe weather they may encounter. And that's just based off of where they live, how they've experienced severe weather, just kind of like any risk. You might have different risk tolerances to driving, to somebody who may have been in car accidents before. So it's just based off of people's personal experiences is mainly the takeaway of this, and just being sure to communicate the risks effectively to the general public whenever they do occur, and making sure to not do any false alarms as well. So now we're going to start getting into the climate stuff, and we're going to kind of start off with a little bit of weather versus climate and the distinction of the two. And it kind of goes hand in hand with those risk tolerances, and knowing that just like in the Oklahoma study, where if you had weaker storms, and they were smaller, they were further apart from whenever you experienced them, you're probably not going to be as knowing to those or reactive to those watches and warnings versus somebody who has experienced those. Tornadoes as they were stronger or have had more of a significant impact on your life. The same thing kind of goes with climate as well. And so people who experience climate disasters are probably going to have a much higher response to climate change and the fact that they're going to want to make their community more resilient or move, or if they have the ability and such as well. So it kind of goes hand in hand in a way, but also I kind of wanted to go into like attribution studies of weather versus climate. So weather is just like the day-to-day variation, and climate, as you know, is the long term. So an attribution study basically tells us how much of an extreme weather event currently was enhanced by climate change. Because I can't just point to the Middlebury tornado and say, that was climate change. Instead, after the fact it happens, we can look at data sets from historical data and say, okay, well, in the instance of like Hurricane Harvey, for example, we can see that Hurricane Harvey's precipitation, it was 15% higher under a current climate than it would have been if we hadn't been pumping CO2 in our atmosphere since the Industrial Revolution. And basically what we do is we take two climate models, one without us pumping in CO2 in the atmosphere, and one with business as usual, what we've been doing, and we run them and we compare the two and see how they react to what we've been doing. One without as much CO2, one with as much CO2. And basically the biggest distinctive factor in that is one has a lot more water in the atmosphere than the other one does. So when it comes to extreme precipitation, it can be easy to tell in some cases, especially in larger duration events. You can kind of tell in those situations if climate change had its fingerprints on an event. Also, wanting to note the Pacific Northwest heat dome. That fingerprints of climate change all over that. Like attribution studies happened for it, and they were like, oh no, this is like climate change, 100%. And so tying that also into whenever we talk about 1 in 100-year storms. Basically that means that it's a 1% likelihood that we're going to have a 1 in 100-year storm this year. As opposed to, it's only going to happen once in 100 years. It's a 1% chance over the course of a year. And actually, fun fact, statistically, it's 63% chance likely that it would happen over a 100-year period, the way the math works out. But as our planet warms, those 1 in 100-year events turn into 1 in 25-year events. And they happen a lot more frequently as we destabilize the climate system that we've been knowing and loving. So kind of going into more of the heavy climate stuff is a little bit to start is my own research with climate change. So I did climate modeling my sophomore year summer of college. And this is under RCP 8.5. This is basically business as usual, worst case scenario of climate change. I will like to say that I would like to stipulate it's not going to get this bad anymore. And that it's actually going to fall probably around 4.5. And that climate scientists no longer really use 8.5, the worst case scenario, as the standard scenario when it comes to climate modeling and to conducting studies. Because since then we've had significant policy changes that lead us to believe that our emissions are going to be drawn down to where we're not pumping as much CO2 in the atmosphere anymore. So we're not going to be seeing as drastic of changes. Yes, we're going to be seeing changes that are still significant, but they're not as bad as we once believed. They're still significant. And so basically what this shows is, the main thing I wanted to emphasize is this is the top 10% most severe precipitation events in Vermont over the course of the year. It's over different global warming benchmarks. So when we hit 1.5 degrees Celsius, 2 degrees Celsius, 3, and 4 over the course of the century. And essentially what it's showing on the plots is it's the 10 years, 5 years before and 5 years after the year that we hit that benchmark average, and then spatially shown over the state of Vermont. And really the main takeaway here is extreme precipitation is going to get more extreme, but also it's very spatially dependent in the state of Vermont. And because of the terrain we have, the influences from the Atlantic Ocean, the influences from the St. Lawrence Valley. We get a lot of Canadian influence, and we also get a lot of oceanic influence. And so over the Lake Champlain Basin, we're going to see various changes depending on where you live. And so the one streak though right here, this is actually right near Rutland, kind of the spine, height of the spine of Vermont. and that's going to see probably the most significant changes in precipitation over the state. And so this is just kind of showing it over a 100-year period of what it could be if we were still doing business as usual. This is also just the annual precipitation changes over the year. And it's in millimeters, and 100 millimeters may seem like not a lot, but on average, our precipitation going up 4 inches over the course of a century, or less than a century, is kind of scary, seeing that we've already increased our annual average precipitation about 6 to 7 inches a year. And so that has significant impacts in terms of flooding, which we saw in Tropical Storm Irene, for example. Whenever you have those significant flooding events, the state of Vermont, even though our infrastructure is sort of prepared for that in terms of what VTrans considers their standards now, is a little bit like not enough at the same time. And so this is kind of what the annual precipitation is showing, is like we're just going to keep getting wetter, and when it's wet, it's going to be a lot more wet. It's going to rain a lot harder. So also to go along with that, the thunderstorm potential. This is showing the change in CAPE, which is a measurement tool that we have to show the fuel that's available for thunderstorms. It kind of just shows the instability in the atmosphere. And so it shows the changes throughout the United States of where the CAPE values have changed over time. Historically, what we've seen since 1979, and this is a graphic from Climate Central, which is an awesome organization that does all sorts of awesome graphics and stuff. But you can see here in Vermont, we've increased about, on around a scale of about 40 joules per kilogram. 1,000 joules per kilogram is about the standard for what you would consider good fuel for thunderstorms and stuff, and it's decreased a little bit in the west. And that's just because a lot more moisture has been available in the east because of a warming Gulf. Also, extreme heat here at home in Vermont, we've seen, this is from the National Climate Assessment. The graphics are a little wonky because I didn't split them. But the summer temperature, you can see it's risen. I believe we've risen 3 degrees Fahrenheit, a little bit warmer on average for the year. This is just showing summer, but you can see our summers are getting a little bit warmer, but the main concern for Vermont for health reasons is actually going to be our nights. So warming nights pose a bigger, a little bit more of a concerning trend when it comes to human health, especially in areas with less air conditioning like Vermont. This is just because our bodies need to be able to cool off at night. We all sleep with our windows open in the summer traditionally, but if that nighttime temperature isn't dropping as low as we want it to, such as in like the 60s, lower 70s, where our bodies can adequately cool down, and we're sleeping in 80-degree temperatures, our bodies aren't going to be able to cool, so we're taking on more heat stress. And so it can lead to more adverse side effects, especially amongst older populations, infants, and anybody with any other pre-existing health conditions. And even really fit people, it still causes more stress on their bodies. And so important to note that 2/3 of Vermont homes have access to air conditioning currently. That's including window units and such, and the number of homes with actual central air is much, much lower than that. And that's a really important tool to being able to have regular temperature. Yes?
So I'm seeing the bar graph, and I'm curious about what the spikes are above and below.
Yeah, so basically this is kind of showing the tips and tails and the noise of it. So this is kind of the average piece here, and this is just the noise that kind of shows up in
how hot it can get.
How high it can get, and you can see the lows aren't getting as low, the highs are getting much higher in observed number of nights where we start to see those things. So yeah, so we're starting to see more nights warming, and you can kind of see it also in the last 5 years as well. And this is over the U.S. This is Vermont as comparison. Vermont is warming much quicker than the rest of the United States is. And then just overall projected future temperature changes in Vermont. We're no longer probably going to be in that high emission scenario. We're probably going to end up somewhere between here and here for our mid to low emission scenarios for what we're going to warm. But we've warmed about 3 to 4 degrees Fahrenheit so far. We're probably going to continue warming another 3 to 4 degrees Fahrenheit, but nowhere near the 15-degree Fahrenheit top there. And also just, if you're wondering why these are so big, is because it kind of shows the variations in the climate model simulations and then the different assumptions they make depending on human activity. But yeah, so this is my presentation. I know it's very long and very filled with science and pretty full of information, but I'm happy to answer any of your questions, go back through slides and recap anything. So yeah, thank you guys so much. Yes.
So you lived in Texas?
Yes, I grew up in Dallas, Fort Worth.
Which of them has the scarier extreme weather from your perspective?
From my perspective, I'm going to have to say Texas. And the reason is, so I actually go back to this slide. And I grew up there just long enough to be able to see the changes extremely significantly. So Texas actually isn't warming where I live all that much. The winters are warming significantly, but the summers aren't doing too much in terms of like significant warming. It's warming a little bit, but not a lot. The winters are what's being warmer. But the main difference that we're seeing in Dallas-Fort Worth is the increased precipitation, to the point where we have events like this one, which my parents had sent me a picture of that a couple years ago. That is a completely dry golf course that flooded. I think we got 6 inches of rain in the course of a few hours. And so the scary part there is that the areas that used to not flood are now flooding. That used to not be floodplains are now becoming floodplains. And that's on top of drought. And whenever you have drought in areas and it dries out the soil kind of loses the ability initially to be able to absorb as much of that moisture at first, and it doesn't become as an effective of a paper towel to say. And so it just runs off at first, and then it's able to absorb a little bit slower. And so basically it's raining harder than the soil can absorb it, so you're resulting in a lot more runoff. And so you end up with flooding events like this. And so it's a little scary. Like, luckily the town I live in, they have engineered the city around the creek that goes in, and that's the creek overflowing in this case. But they designed it to where the park system is built along the creek, so it acts as one big floodplain, especially the nature park and is in the area that it floods the most, which is also attached to the golf course, which acts as a flood barrier to residential areas. So you might have more, unfortunately, like pesticide and herbicide runoff from golf courses and fertilizer and stuff going into the lakes. But it acts as a buffer, but a lot of areas aren't so lucky. And so in the south, you're seeing, because of especially a warmer Gulf of Mexico, because that body of water has warmed so significantly, there's so much more moisture available than it would be up here, to the point where you're getting like downpours of rainfall, and then you get these really long periods of just dryness. So our wet seasons have gotten significantly wetter. So yeah. Also, it's kind of important to note that tornadoes are increasingly occurring at nighttime too, and so that poses a whole new hazard. That severe weather is starting to extend more in the nighttime because we're not cooling off enough, so the instability in the atmosphere is still kind of there, and you still have rising motion to be able to fuel these storms. So because it's not cooling off as much at night anymore, you're starting to see tornadoes and thunderstorms occurring later at nighttime and in more forested areas to the east, such as the southeast, and so that poses a really big hazard for communities and such to be able to respond effectively. I've actually slept through a tornado, fun fact. Unintentionally. Yeah.
I guess my question is sort of sociologically oriented,
Yeah.
and your slide of the perception of severity made me wonder what you've observed, or what you know, or what has been studied about the perception of the severity of weather and weather trends as it is perceived by different generations.
Yeah, that's a really good one. It's interesting. Like, I guess it depends on geographically where you are, is like an important thing. Geographically, in terms of, if you're in the southeast, no matter what generation you're part of, especially if you're in a little bit of an older generation, you didn't grow up with as many tornadoes that exist now. So the risk tolerances there are going to be a little bit more, oh my gosh, why are we getting a lot more tornadoes I'm seeing now than where I live at home, where we might be seeing a little bit less tornadoes occurring as tornadoes are shifting eastward, which is still a very active area of research. But it kind of depends on where you live and what the generational like thought is on it. At home, it's a little bit more concern of older generations of precipitation, in that the seasonality of precipitation was a lot more predictive, and you get this a lot if you talk to like farmers who used to be able to rely consistently on whenever the first rain would happen, freezes and thaws, especially as well for planting crops. And so like my grandparents, for example, they can say, oh my gosh, I'm noticing all these changes, or I've noticed all these changes, but for me, for example, although our climate system is changing very rapidly, I can't reference, what a more stable climate used to be like, where I did experience those once a lot more predictive seasons. And so, there's a little bit of a toss-up in risk perception there, I think. And it just depends on what you grew up with, too.
You talked about increasing average rainfalls, and a lot of these more extreme events involve moisture, and yet I feel like we're having more drought here in Vermont than we used to.
Yeah, so interesting enough, I didn't include the parts of my research that break up the seasons. The seasons in Vermont are very different in terms of what they're doing. So fall, for example, would be a drying season, and it's projected to get drier across the state, even though on average it looks pretty much flat if you kind of like average the whole bubble. But if you spatially plot it out on a map, you can see most of the area is actually getting drier. Also, the fact that snowpack is melting earlier, even though the amount of snow may be similar season to season, if you get more freeze thaws in the winter and that snowpack decreases, you're going to have a little bit of a drier start to spring, especially in terms of vegetation, as it shows now, to where you're going to have more red flag warnings, for example, from the National Weather Service being issued. So Vermont's biggest impact in terms of severe weather is going to be more intense rainfall. But then also, a lot of climate scientists are finding, when it rains, it really rains. And then you're also getting longer periods of dryness as well. And so basically we see these large systems that move across the United States, high pressure and low pressure systems, starting to park themselves over areas longer. So a low pressure system is going to park itself over an area maybe a little bit longer, so you're going to have more rainfall happening, versus the high pressure system is going to dry out an area for a little bit longer too. Which kind of goes into like the noise factor. So like it kind of still shows like a seasonality here, which is the noise, but it's important to like noticeably distinct the smoothing line, which kind of averages it out, so that way you can kind of conceptualize the trend a little bit more. In that like the rain shadow here, even though it's not the most like visual here, you can see the rain shadow on the backside of the spine is becoming a little bit more, would become in this scenario, a little bit more extreme, where you're going to have wetter on the front side of the mountains, and then on the leeway side it would become drier, and that's just because it's bringing out a lot more moisture than it would, and that's not because our mountains are changing, it's because our weather systems are changing.
So thinking about the effect of the mountains, is Burlington then the place that does the National Weather Service for the entire state, or?
Yeah, so the National Weather Service geographically, the National Weather Service is located in Burlington International Airport. If you've ever walked in the airport on the civilian public side before you get into go through TSA and stuff, you can pass a seal, or whenever you're leaving your skinny pancake, you go left instead of going out. You pass the National Weather Service office in there, and there's also designated parking spots for them. But the National Weather Service essentially covers North Country, about right here in the Adirondacks, and then it kind of cuts off in Rutland County and in Bennington County. The National Weather Service in Albany actually services that part of Vermont just because they're closer. But the National Weather Service in Burlington services pretty much right about here geographically. So, and you can look up all the National Weather Service office maps. There's a really good picture of them. There's a lot more offices than a lot of people think. There's a specialized office just in Key West that only services Key West, Florida, for example. And so each one has different geographical areas, and it's usually sectioned off by counties. Yeah. Olga, I know you kind of raised your hand.
Yeah, I was kind of riffing off of the question, the kind of sociological question, the idea of risk and how people respond to risk, whether there's a prepared, you talked about like people not being quite as prepared for winter weather. And then, but you were saying that, you know, a big challenge is also summer weather. And so how we should be preparing for that is like, okay, I gotta go to that app and, you know, that thing on the weather.gov. But then I was thinking about, you know, just general responses to climate change, you know, and whether these high-risk circumstances and the things that we're perceiving as risk or potential risk, or just at least just noticing that it's raining more or raining less, or it's hotter or it's colder. I don't know if this is the thing that your work tracks, you know, but is what is people's responses to this stuff, you know? And I know there's a certain amount of activism, but I don't know, you know, there's also a certain amount of like, well, it's the weather, you know, and or at this point, like, I'm recycling, what else am I going to do, you know? So I was kind of heartened to see the comment, you know, your comment about emissions not being quite as expected. They were going to be higher, and they're lower than carbon emissions. So I'm just curious, like, where that all falls into play in terms of activism, perhaps.
Yeah, there's like there's been a huge shift. AMS is the national governing body for meteorologists. It's American Meteorological Society. It's similar to like, I don't know why I can't think of any other bodies, but like you would have the American Association for Pediatrics or something. But the American Meteorology Society is a giant society of meteorologists that come together every year at a conference and a bunch of mini conferences throughout the year and stuff to share their research. And there's been a humongous shift in meteorologists in their careers, and that being a meteorologist is no more just like day-to-day weather. I'm communicating the weather. These are the risks happening now. But it's also turning into meteorologists becoming more involved in emergency management and becoming more involved in education and outreach and like educating the public on these issues. And that you're seeing a lot more scientists in general, but meteorologists specifically, going out into the public, kind of like this talk right now, and like trying to educate the public on these hazards and how you as an individual can mitigate the hazards that you might expect on a day-to-day basis, even though you personally may not have as much control, like the President of the United States might, over what happens to our climate emissions. But you have a lot of control over how you're able to mitigate the risks that you face day to day. I like to think about it similar to wearing a seatbelt while driving. You're in a car, you know, you have these pads in society, which you can factor in as a car. You have an airbag that's there, and it's kind of like a secondary response. But by you putting on that seatbelt, you're significantly taking a hazard mitigation just by putting that on yourself. And then when you're on the road, if you were to get in a collision, you're reducing that, you're mitigating that hazard of you actually being injured or experiencing death. And so, you know, a lot of it has turned into like science activism of like, okay, this is the science. Like, I don't need to convince you climate change is happening, but I need to like convince you like these are the hazards that you're probably going to actively face. Of understanding, saying, hey, your community has a lot of control over what happens. One of the biggest pushes right now by meteorologists is because Tornado Alley is shifting eastward. We don't care if the state of Mississippi or the state of Florida doesn't consider climate change as like human cause. What we care about is that there is a significant population of people that live in mobile homes, and that mobile homes are subject to the most damage and are often the deadliest areas to be when it comes to tornadoes. And so there's been a large push academically to research the hazards associated with it and what areas are being impacted the most from an equity standpoint of these low-income households that are in areas that are poorly zoned and planned, where the building codes aren't necessarily up to standard in the same way that a major city would, to be able to have more resilient buildings to weathering. To being like, okay, I don't care that you're not considering climate change. You need to update your building codes to what the weather is that these people are experiencing day to day, and get tornado shelters installed in these mobile home park communities to, you know, help them mitigate these disasters that they're going to be facing, even though they may not have the resources to do it. And so that's kind of what it's turning into, of like less education on like climate change is happening, but how you can take matters into your own hands and take, you know, the power that you wield in your circle of influence in your own community, whether it's showing up to a city council meeting and saying, hey guys, in your zoning laws, like, we need to update them to be better prepared for flooding that may occur because of Otter Creek, you know, in the future, and that our downtown may be more exposed. Vermont is very exposed to flooding, and that's because all of our downtowns are on rivers, because it's a very cold place, and that's where settlers built. And so like it's turned into a lot more education on like how to mitigate, react, adapt to these changes and what we're seeing.
Can I add to that a
Yeah.
little bit better? Just because I think there are some really, really great resources through like the Yale Program on Climate Change Communication and lots of these surveys that look at all of these trends in perception and risk tolerance and stuff. And they also have some really great, I used to work with them a lot when I was at Yale, and they have some really great, they're like climate opinion maps, and so you can actually drill down by district, by state, by everything, and then you can filter by all of the different kind of things. And so you can get a better sense too of like where people, you know, the kind of some of the influences and like and change over time too. So like the surveys have been running for a long time, and you can see really, really marked differences between what people would, I mean, both in terms of like their perceptions of extreme weather, but also then their perceptions of what they would do. And so this goes to more of the activism question of kind of on an individual and personal basis, where like you see shifts over time into what people would be willing and interested to participate in. So those are also some really, really great resources.
Yeah.
Kind of tying into the perception and like I think a lot of times I've noticed in the past several winters, out in January or February when we have one of those warm 60, 70, 80 degree days that we've seen, and you're out and about, that I think reduces people's perception of it's bad. At least from what I experience, people, you're out and about walking around, it's like, it's so nice out. I'm usually like, no, I'm concerned. This isn't the way it's supposed to be. And trying to have that conversation of like, yes, it feels nice. However, we should all be concerned about this, not happy about this. So I think those kinds of things can definitely have a huge effect.
Along the lines of that, that's a really hard line to be able to communicate to the general public, is like those climate signals that pop out every now and then of like these really warm periods in winter where we get heat waves. And you're like, oh, this is such nice weather. And you want to go enjoy the weather because you're like, I've been stuck inside. It's cold. This is actually nice and I want to take advantage of this. I like a temperate, day that I can go out and walk and enjoy the outdoors and stuff. But then also it's like, red flag, hi, climate change is here. You're going to see a lot more of this, but this may be one good thing that's happening, but the disasters down the road are kind of like lingering there, like kind of festering.
Sort of part of the taco.
And it's kind of part of the taco. It's like, oh, this is great, but then what's the aftermath?
Oh, I can speak to that because I talk to people about weather all day, as some of you might have already done. Like, we have that conversation probably every time this happens. I think the interesting thing is, like, in having, like, I take pretty much every conversation down some, like, pretty depressing road just because I'm, like, talking to people all day about, like, all the stuff that's happening in the world. But it's, like, generally people do understand that, which is what's interesting. And it's, like, because if you like go a little bit further, then like, oh, it's so nice out, but almost everyone will be like, but yeah, I think that's really bad. Like, but yeah, that means that everything is terrible. But it's interesting because people on the outside, like you don't go anywhere under the surface. They are like kind of going around like having a great time, but I think there needs to be a little more like acknowledgement of like what's actually happening. But I guess we're not, it's not so like intense yet here in terms of like we have like a couple days here and there. It's not like totally shifting yet, and then it'll be too late anyway. But I just wanted to say because that's like an interesting thing that I think about every time there's like an outlier day. It's like people really do know what that means, but they don't want to talk, or people don't usually want to talk.
Today is 86 degrees.
Yeah, right.
Today is 86. We might have shattered a record. Albany Airport. So Albany recorded the earliest day above 80 degrees ever on record. So that's like a little signal that pops up every now and then from climate change. And so it's hard because like it kind of takes you back to like the tornado of like, okay, great, we have like less intense tornadoes here, so my risk perception is, okay, well, not all tornadoes are that bad because maybe I have some shingle damage, I have to replace a couple windows, maybe I have to like fortify my garage or, make some small adaptations in my home. But then, it kind of shows the inequities of climate change too, of like, you might have more severe disasters in these other areas that have, a lot higher risk perceptions of these events and will, want to take more action, but maybe they aren't able to. Or, you know, you try to focus on, oh, well, it's not so bad over here, but, you know, you have a lot more of a risk of disaster in over there. And so, you know, it's these days that are like, those smaller and it's not so bad, and then you get into the summer, and then all of a sudden you're outside. If you work outside all day in the summer and you're stuck in a heat wave where it's 95 and humid, your body can't regulate its temperature as well because the wet bulb temperature is much higher, and so you're more likely to have heat-borne illnesses like heat stroke, heat exhaustion, and so, you know, it's that kind of stuff.
Well, I think we're sometimes our own worst enemy because psychologically we can't hold the reality
Yeah.
of this climate crisis 24 hours a day. So we get a nice day and we embrace it as a gift and go on and enjoy it. So I think we're in, what I angst over is it's one thing to do what you're talking about. How can we take care of ourselves, me, on an extreme weather day? What can I can have my little kit and so on. But if we're really going to impact future generations, we've got to work at a much greater level of political change. And that's, I just find that the hardest part of the work to be done.
I'm along those lines because I feel that as well. I'm wondering, you know, and I can feel meteorologists kind of, because I watch the Weather Channel, right?
Yeah.
And people will sort of dance around climate change, you know, and they'll talk about, well, with the changing weather, you know, and they're sort of euphemistically addressing it without actually coming out and saying, no, it's a thing, it's actually happening. Here it is, it's happening, and that's why we're having this like shift in where the tornadoes are crossing and weather changes on a large scale. And I wonder your thoughts about the responsibility I 100% agree and understand that one responsibility is to let us know what's happening. We get it. You know, you don't care if we believe it or not, but help us be prepared and mitigate these coming circumstances, not the present ones. But what about the responsibility to verbalize from our trusted sources, which are our meteorologists, because you are trusted.
Yeah. Yeah, no, I totally hear that, and it's so important for that. And luckily, now we have organizations like Climate Central, who is founded on the fact that broadcast meteorologists historically don't have enough airtime. They haven't had the tools and the time and capability to put these things together in their weather graphic systems that weren't available, of building these weather graphics that you can do from scratch, to incorporate extra tools to be able to communicate these changes to the public and understand the hazards and the risks. And now they also have just launched a new piece to it that is all about renewable energy and how renewable energy is actually performing compared to what the public perceives it to be under the day-to-day weather. They're tying those solutions into forecasting. And you can look at Local 22 and 44 or NBC 5, for example, and I think WCAX also has one. But there's more channels now that are doing specialty mini packages within their newscasts that are directed by the meteorologists, and where they're going out and telling climate stories, or they're diving into the climate science for the average viewer to be able to digest, and then also it's kind of expanding. But the TV market has been very taboo about talking about it, and it's been very conservative. And it's the ownership of the stations, because you can't do anything that's going to make your station manager upset and whatnot. And so also the other part of journalism is you want to be able to tell both sides. Climate change is not one of those issues that is a both sides thing, because climate change is happening, but because it has been perceived by intense lobbying as such a both sides thing, it's been a very much silencing act of we're not going to say anything at the risk of our own jobs, even if we understand the fundamental pieces of science that prove that this is happening, because as a journalist you want to be able to be unbiased and tell both sides of the story, but because it's been pushed in the public narrative and in
As
the
an opinion.
as an opinion,
Yeah.
and in the management of these large media corporations as an opinion, and stuff as special interests, then it's become a lot more. It's been a lot harder to get to that point until now, where it's kind of been like it's so in our face that meteorologists are actively like telling their station managers, like, no, I'm talking about this. Like, I have a friend in Michigan, and their station didn't really have like a climate segment, and she approached them, 2 months into her job, whenever she was like comfortable, had her feet under her and everything at the station. She was like, we need to be able to like, I'm gonna start putting climate graphics into my show and like start talking about it on air and getting them to like incorporate it more in these newscasts because they're covered in stories whenever it's natural disasters. And so, communicating those risks, communicating how to mitigate those risks too, and what the solutions are, and making sure people also understand like it's not all doom and gloom, and that climate scientists are like, hey, the biggest uncertainty is what we choose to do as humans. Like that is the one thing that is very much not well known enough, and it's like, oh, it's either doom and gloom or we are like going to be perfectly fine. No, it's like we have the choice of what we want to do, and so it's how do we communicate that to the public, and that there's such large spheres of influence in media. Like how do we get more media out there that's especially targeted in those positive areas, and even when there is a negative climate disaster, how do we tie in those stories that are able to uplift those communities and bring those solutions to the table of just saying, my community was wiped out because of an intense flood. Okay, well, let's talk about like how that impacted our community, but how we can take steps to further mitigate those, and then also tie in, we can still reduce our emissions to where we can end up in those low emissions scenarios too. So, yeah. Those are very long-winded answers.
Can I make another comment? I
Yes.
know we're over time, I'm so sorry. But I just feel that also one of the sad things about it is that we're working, let's say a meteorologist is addressing their community, and their community may be doing what they can, but their community is not necessarily responsible,
Mm-hmm.
right? And so it sort of requires a real, like, an empathetic response globally,
Yep.
right? To understand that although you're doing fine up in your penthouse or whatever, forgive me, but you know what I'm saying. Like, these people who are fine don't understand the implications or the ramifications of their decisions that they make on a very high level power and influence and control, that then ultimately results in people who live in mobile homes in Florida, for example, suddenly experiencing these tragedies, this weather that's so severe, caused by a certain inertia on the part of people who don't take it seriously.
Yeah.
And I find that just really frustrating.
Or they take it seriously, they're just,
Well,
Yeah.
sure, yeah, but not seriously enough, is it?
no, I mean, they do, I mean, there's entrenched interest in in taking it seriously in a very different way.
Well, sure. Sure. Anyhow, that's not helpful, perhaps, but I find it, I appreciate the efforts being done locally, and I also recognize that ultimately it's about big power shifts.
Yeah.
Oh, well, it's 100 companies that are responsible for
Right, exactly.
70+% of all of that stuff. So
And
it's
I will leave actually off on that. I did forget to mention one more thing. I'm so sorry.
no.
No. Yay!
One more thing with attribution studies. So these are actually starting to be used in lawsuits for climate change, to where so far they've been largely unsuccessful because it is one of the youngest pieces of climate science is attribution studies, but they are also one of the fastest areas of advancing research in the climate field. And now we're starting to get to the points where we have universal science standards to conducting these studies, whereas before, just like starting any new area of research, like the standards aren't quite clear, so you're trying to figure them out, you're like kind of establishing a scientific basis and consensus. Now they're starting to become a more broad consensus on how to conduct these attribution studies and how to go about doing them and communicating them to the point where they are, where they're starting to be implemented in these court cases where there are these local communities such as San Francisco suing ExxonMobil to where they are able to say, hey, this, flooding event is, or like Hurricane Harvey, this flooding event was 15% higher precipitation because of climate change. you need to pay up to get, you know, to help rebuild our community because you were directly involved. Now, it's a very wishy-washy law you know, field topic and stuff, and I'm not a lawyer, but like science is like the science is starting to get to also new bounds to where they can start using this of like strategy to try to push these changes in their communities to hold these people accountable and to try to enact these larger changes as well. And so, you know, that's another bit of hope and like kind of fun thing that's happening in the climate field. Like it's all about like doom and gloom studying our demise. It's like, oh, like how can we like actually pull out these climate signals and use them to repair the damage that's been done and build more resilient communities.
Okay. Yay!
Yay!
So thank you all so much for coming out for Middlebury Science Cafe. Oh, exit that way.
Oh, all right.
Otherwise you're walking. That's cool. So thank you, Patrick, for your wonderful talk, and thanks, Matt, for bringing some wonderful coffee. We still have some nice snacks, so especially if you are concerned about spoiling your dinner, please take a cookie to go. Next month, coming up in May, we're going to have Dr. Greg Pask come and talk, and he's going to share his research on fireflies. Yeah, fireflies in Vermont that don't light up. And what do they do? How did they get that way? Just answer some really awesome firefly questions in preparation for firefly season. So yes, thank you all so much. This is made possible by the Center for Community Engagement at Middlebury College, along with MidData. And our funding is coming from the Provost office. So big thanks to Middlebury, Patrick, and Matt.